All right, so we're in Tech Math 2, and we're in section 7-2. All right, so 7-2 says, well, we'll do some theory. You know, we don't do much theory, right? If I have something that's ax squared plus bx plus c is equal to 0. If I have something like that, then, and I know how to complete the square. Now, completing the square happens probably in chapter 8 or 9, so we'll get to it sometime. But in order to complete the square, we put this x squared plus b over a x plus c over a is equal to 0. So that when you complete the square, you make the coefficient of the x squared term 1. All right. And then you say, well, you take half of the exponent in front of the x term. So I'm going to take b over ax, and then I'm going to add b over 2a, and I'm going to square it, and then I'm going to subtract b over 2a, and I'm going to square it, and then I got plus c over a is equal to 0. All right, so if I do that, then this guy here becomes x plus b over 2a squared. Because if I multiply that times that, and I have 2 of them, then the 2 goes away, and then it becomes this. And then on the other side, I've got is equal to, I have c, let's see what I got. I got b over 2a squared minus c over a. Okay, so I put that on the other side of the equation, put that on the other side of the equation. And then I said, well, if I go in, I don't know what I want to do. If I put I need a common denominator is what I need. All right, so I've got a 4a squared on this side, so I'm going to want a 4a squared over there, so I want a 4a on top. Okay, now I've got a common denominator. All right, so I can have x plus b over 2a squared is equal to b squared minus 4ac, if I put it in alphabetical order, divided by 4a squared. Okay, that's good. Then I can take the square root of both of these guys. I take the square root of both of those guys. X plus b over 2a is equal to square root of b squared minus 4ac over 2a, and then I can have x is equal to minus b plus or minus, because that's really a plus or minus when I take the square root of b squared over 4ac divided by 2a. And then we call that the quadratic formula. So we normally don't show that the quadratic formula is right. You know, we don't show the math that gets to the quadratic formula. We just say, here it is, use it, kid, right? That's what we normally do. But this time, because you're so blessed for having such a great instructor that you do, you get to see the proof of how do I get to it. All right, so if I have a situation where I have a squared plus b, a x squared plus bx plus c is equal to 0, then I don't have to factor it. I don't have to do anything. This is going to be minus b plus or minus the square root of b squared minus 4ac over 2a. Now that's what you've been told for your entire adult life, ever since 8th grade, right? Okay, what I'm telling you is that there's another one. This is called the quadratic formula. But there's another one that's called the half quadratic formula. And it says that if you can put your equation in the form ax squared plus 2bx plus c is equal to 0. Then you can say that x is equal to minus b plus or minus the square root of b squared minus ac divided by a. And now you're to the point where you can do this in your head a whole lot better. Well, maybe you can, maybe you can't. But you can put it in your calculator and get the answer quicker. So what I do, if the guy in front of the x term is even, I change it to 2b and use the half quadratic formula, and that takes away half of my fumbling around on my calculator trying to get the right key. Okay, and but then again, I wouldn't do either of those. I just have it solve the equation as a quadratic and tell me the right answer anyway on my calculator. So that's probably what I would do. So there's two equations, the quadratic formula which you were given since 8th grade, and the half quadratic formula, the first time, which the math department hides from you and doesn't show to you because it makes life easier. And I didn't get to see that as a math major. As a math major at UNO, graduated in '72. I didn't see it then. The first time I saw that was in a complex variable class at UNO in 2006 or thereabouts. Okay, so, but there are two of them, and one of them's an easy one to use, and one of them isn't. All right. Well, that's what's on page 267, the quadratic formula, and as long as we call this guy right here, that guy there, so the square root of b squared minus 4ac, or the square root of b squared minus ac, depending on which formula it is, we call that the discriminant. I would spell it, but I don't know how. And if this guy is negative, then you have imaginary numbers associated with your answer. If this guy is a square, then he's a whole number and that. And if he's not a square, then you got a irrational answer and all kinds of cool things. But we don't care about any of that. But if you're doing a number theory class, you might care about that. But we don't really care about it. So now we're going to do number 1. And so I got x squared minus 4x minus 32 is equal to 0. So I'm going to do it two ways. So I'm going to use the quadratic formula and say x is equal to minus 4, which I wouldn't really do. I'd just put down a plus 4, right? Plus or minus the square root of minus 4 squared, which I wouldn't do either because I just put a 4 there. Minus 4. Oh. Oh. Okay. I'm sorry. I was on section 7.3.
Oh.
Yeah. All right, well, back to section 7.2, which has to do with completing the square. Oh, yeah. Okay. So, how do I complete the square? I got something in the form ax squared plus bx. What? Who put a square there? Plus c is equal to 0. I want to be in the form x squared plus something, so I'm going to divide everything by a. And then I'm going to go in. I'll do that tomorrow. I'll show how to get the quadratic formula again tomorrow. No, I won't. And then what I do is I write it x squared plus b over ax. I leave a space, and then I go is equal to minus c over a. I put that on the other side. Now, I want something so that when I get done, this term becomes something squared. Okay, and I remember that if I had a plus b quantity squared, then that's going to be a squared plus 2ab plus b squared, right? I remember that. So obviously I want this guy to be something that can be, when he's squared, he becomes this b squared term, right? and I want that divided to be 2ab type thing. So I'm going to add b over, all right, so where were we? 2a, the quantity squared. So now I'm going to have x plus b over 2a is what that's going to turn into, because now I got my x squared term. There's my x squared term. Here's my b over 2a squared term sitting there. And then I've got two of these guys. I got b over 2ax plus another b over 2ax, which gives me just b over ax. All right, so if I add that to the left-hand side of the equation, I better add it to the right-hand side of the equation as well. So I can do that. And then I have this as minus c over a plus b squared over 2a. Now, why would I want to do that when in the next section I'm going to use the quadratic formula, and I'm not going to do that anyway because I'm going to go and put it in my calculator and my calculator do it for me. I mean, so, but anyway, this is a math class, so we have to do math every now and then. Otherwise, the majority of the class would be totally bored because you're paying for a math class, right? All right, so Nate was confused about number 1 last time, rightfully so. So we're going to try number 1 again. X squared plus 6x minus 16 is equal to 0. I look at it and see if I can factor it. Oh, this stupid thing doesn't factor. What am I going to do? Yeah, it does. Yeah, this thing factors. Why am I even doing it this way? This thing factors. X plus 8, x minus 2, and is equal to 0. So clearly my answer is going to be 2 minus 8. And I put it in the wrong order, so I'm wrong order, bad answer. X is equal to minus 8, 2. So now I'm spelled correctly. Now my spelling right. Well, but I'm in section 7 too. So that means I'm supposed to do it by completing the square. So you got some test, and it tells you to do it by completing the square. And what are you going to do? Well, you're just going to put in your calculator, write down the answer. Oh, anyway, so I'm going to have x squared plus 6x. Half of 6 is 3, right? So we're going to go plus 3x, no x. 3 squared is equal to 16 plus 9, because I look at 3 squared and I see that that's 9. If I put a 9 here, I got to put a 9 there. I could have gone and just borrowed from this 16, right? I could have done that too. Anyway, so I got x plus 3 squared equals 25. I got x plus 3 is equal to plus or minus the square root of 25. I got x plus 3 is equal to plus or minus 5. So x could be minus 8, x could be minus 5, minus 8, or minus 2? No, plus 2. Okay. But why would I want to do that? Well, as it turns out, we do have another section of the book where we're going to have to complete the square. So we're going to have to practice completing the square. So when we get to that section of the book, we can figure out how to complete the square. All right, so I'll do a problem from there. So if I had x squared plus 4x plus 9, well, we won't go with a 9, we'll go with just an x squared, y squared plus 8. 8y is equal plus, let's say, we'll do a plus in here, plus 35 is equal to 0. What is that an equation of? And you say, well, how do I know? I'm only in Tech Math 2, section 7 dash whatever. We haven't figured out what that is the equation of. Well, that turns out to be the equation of a circle. So now the issue is, where is the center of the circle? Okay, well, what you do is you say, well, I'm going to complete the square and say that this is x squared plus 4x. I'm going to divide by 4 by 2, and then I'm going to square the 2, and I'm going to put a plus 4. I'm going to remember I need a plus 4 on the other side of the equation. And then I got a y squared plus 8y. I half the 8 and I get a 4. And I square the 4 and I get a 16. So I'm going to add 16 to that side of the equation. And I'm going to add 16 over here. I'm going to make this a minus sign so that life is wonderful. And then I'm going to have a minus, another plus 35 on this side. And then this is going to be x plus 2 squared plus y plus 4 squared is equal to 55. And then I'm going to say, well, in the form x plus h squared plus y plus k squared. Notice the difference between the h and the k are very distinct, different, is equal to r squared. The center is going to be at minus h minus k. And the radius is going to be r. So in this particular case, the center of this circle is going to be at minus 2, minus 4. And the radius of the circle is going to be the square root of 55. And I can't solve the problem unless I can complete the square. Okay. So when we get to chapter whatever it is that has to do with analytical geometry, we'll need to complete the square. And that's why we're doing it now, so that you can forget about it between now and then and have to teach it again next time when we have to use it. That's the way it works, right? Yeah, because it doesn't matter that your calculator can find the right answer now. You're still going to have to complete the square in order to do that type of problem. Okay, back to number 3. I got x squared plus 12x is equal to minus 35. And if that were the problem, that'd be one thing, but seeing that it's not, let's see, x squared minus 12x minus 35. All right, is equal to minus 35. All right, so I'm going to go and take half of minus 12 and get a minus 6. I'm going to take the minus 6 and I'm going to square it. And then I'm going to add it to the other side of the equation so that I haven't contaminated the problem with something that I can't do. All right, so now I've got x squared minus 12x plus 36 is equal to 1. All right. Yeah, 36 minus 35 would be a 1. This guy becomes x minus 6 squared is equal to 1. I go and I take the square root of both sides. And I say x minus 6 is equal to plus or minus 1. It is. Yeah, because I could square it, plus or minus 1. So x is going to equal solution set minus 7, 5. So no, plus 7, 5. Plus 7, 5, which means I got it written backwards, 5, 7. So 5, 7. So that becomes a plus 6 when I put it over there. 1 plus 6 is 7. 6 minus 1 is 5. Check. All right. So now I'm going to go and check my work. I'm going to go back to the original problem and just put it in my calculator and see what it thinks the answer is. So I want to do a polynomial solver. I want to solve for a quadratic guy. I want my x to be 1, my a to be 1, my b to be minus 12, and my c to be 35. And I'm going to solve it. It says x is 1, x is 5, x is 7. So my calculator says that x can be 5 or x can be 7, and that is perfectly okay too. And on the next test, that's what I'd expect you to do. You see a problem like that, you put it in your calculator, write down the right answer, move on to the next case. That's what I expect you to do. What's more important, the correct answer or getting there? Well, don't copy off the guy next to you because I gave you the wrong answer, but go to your calculator and, yeah, exactly, whatever. Okay. Let's look at 8. That looks hard enough. That looks worthy of an instructor anyway. 3x squared plus 17x plus 20 is 0. Did I get a 4-0 for writing the problem down right? Okay, so we want the coefficient in front of the x squared term to be a 1. So we're going to divide everything by 3. X squared plus 17 over 3x is equal to minus 20 over 3. So I'm going to put that on the other side of the equation. And then I'm going to say, well, what's half of 17 over 3? That'd be 17 over 6. So I'm going to add 17 over 6 squared to both sides of the equation. Alright, and over here I'm going to have x plus 17 over 6, quantity squared, is equal to whatever this garbage is on the other side. So what do I have? I got minus 20 over 3 plus, anybody know the square of 17? 17. Yeah, that's what I thought it was, 289. I knew that, 289. So I have 289 over 36, and my common denominator, okay, so x plus 17 over 6 quantity squared equals to, common denominator is 36, so I'm going to multiply top and bottom by 12. So that'd be minus 240 divided by 36 plus 389 divided by 36. X plus 17 over 6 quantity squared is equal to 149. 149 over 36. I take the square root of both sides.
It's just 49.
What?
It's just 49 over 56.
It can't be 49. This is 200 and something.
Yeah.
And that's 300. Oh, I see. You're complaining that this number is wrong. You're not complaining about the math. You're just complaining about that number there being wrong. I understand that. I was thinking that taking the square root of 149 was a stupid thing to be doing anyway. So I knew I had a mistake someplace. I just waiting for somebody to tell me what it was. So now I've got x plus 17 over 6 is equal to plus or minus 7 over 6. All right, so x is going to be equal to, if it's the negative guy, it's going to be 24 over 6. 24 over 6 would be 4, right? Minus 4. And if it were the positive guy, that'd be minus 10 over 6, which would be minus 5 over 3. It would? All right. It might be. Let's see. So take our calculator out. Second function polynomial solver, and put a 3 in for the a, a 17 in for the x, and a 20 in for that guy. And if I do that, I'm going to get the wrong answer. So I'm going to have to do it again because I put in the wrong thingy. All right, so I want a 3. I want a 17. I don't want 172. And I want a 20, and it says my answer is going to be minus 5 over 3. I knew that. And the other answer is going to be minus 4. I knew that too. So my answer checks with what's in my calculator, and my calculator wins again. And clearly that's the whole point, is to make your calculator give you the right answer. That's what you paid the 20 bucks for. All right, let's see. We'll do 13 next. but we're not going to do it in green. 13. 3x squared plus 9x plus 5. And we'll look at it now. Can I factor that? No, that's not going to factor. All right. I'm completing the square, so I'm going to change it to x squared plus 3 goes into 9 3 times. So I got 3x, and then I've got a 5 minus 5 over 3 on the other side. Half of that is 3 over 2 squared. I'm going to add 3 over 2 squared to the other side. This becomes x plus 3 over 2 quantity squared is equal to minus 5 over 3 plus 9 over 4. Well, that's a positive number. We've got x plus 3 over 2 squared equal, my common denominator is 12. So that's minus 20 over 12 plus 27 over 12, right? Yeah. Which is going to be 7 over 12. How inconvenient is that? All right, so I'm going to get x plus 3 over 2 is going to be plus or minus the square root of 7 over 12. So x is going to equal 3 over 2 plus or minus the square root of 7 over 12. Now, let's see. This is my calculator in math type. Yeah, it's in math print. Okay. So it should be able to give me that number, I would hope, directly. Which one is it? 13? Okay, so I'm looking at 13. So second function, polynomial, I've got a 3, I've got a 9, I've got a 5, except I got a 50, I don't have a 5. Okay, now I got a 5, and bummer, it tells me this is minus 0.73623733842, and the other answer is minus 2.263762616. Well, I don't know. Why didn't it tell me? Why didn't you just put it in radical form? Stupid calculator. 2 divided by 3. 2 divided by 3 plus. This is a minus sign. All right. Clear out of there. Minus 2 divided by 3 plus radical 7 divided by 12. 0.736267378, yeah, same number. All right. And then we're going to go minus 3 divided by 2 minus square root of 7 divided by 12. Well, minus 2.263762616. Okay, well, that looks good. So it checks on my but I would leave it that way if I was completing the square problem. If I was just writing the answer because it's in my calculator, then I'd do that. And I would probably say, well, I'm not going to accept any more than 3 significant digits or so, and say x is equal to a solution set minus 2.26 and minus 0.736. I'd probably do that. Because writing down any more than 3 significant digits is just a waste of ink in that particular case. Okay. Move on. Is there any weird problem? There's a weird problem. 15 looks weird. Okay, we'll do 15. That's not that weird. 15. Minus 2x squared plus 3x is equal to minus 9. Okay. So I don't like the minus 2 in front of the x squared, so I'm going to divide everything by minus 2. I'm going to minus 3 over 2x is equal to 9 over 2. I'm going to divide by 2 and square it. So that'd be 3 over 4 squared plus 3 over 4 squared. And this becomes x minus 3 over 4 squared is equal to, it's going to be a 16, right? So what's 8 times 9? 72. 72 over 16 plus, is that really a plus sign? Yeah, it is, because it is plus 9 over 16. Oh, that's convenient. 81 over 16. Yeah, that's good. Okay, so now I've got x minus 3 over 4 is equal to 9 plus or minus 9 over 4. Well, isn't that nice? The author made it so it was simple to do. So x is equal to solution set. If this is positive 9 and that comes over here, it's a positive 3, so that'd be 12 over 4. What's 12 over 4? 3. So that'd be a 3. If I had negative 9 over 4 and I subtract away 3 from that, it'd be 6 over 4. But it would still be negative. Negative 6 over 4 would be 3 over 2, right? Yeah. So that's what I'd end up with. And then I'd ask myself, self, is that right? And self being my calculator. And I've got a minus 2. And then I've got a 3. And then I've got a 9. Minus 3 over 2 plus 3. Is that what I got? Minus 3 over 2 plus 3. Yeah. So it checks with my calculator. All right, are we bored yet? Show of hands, how many people are bored? There we go. We're honest out there. Number 20. And then we'll go home. Well, we won't go home. We have 2 more hours to be bored, even worse. 8y squared minus 7y minus 10 is 0. Okay, we want this guy to be a 1, so we're going to write it y squared minus 7 over 8y is equal to 10 over 8. And then we'd say, well, 10 over 8, that's 5 over 4, right? So 5 over 4 there. But we'll probably have to change it anyway because we'll do a common denominator thingy. All right, well, half of this guy is 7 over 16. So I want 7 over 16 squared plus 7 over 16 squared. So we got y minus 7 over 16. The quantity squared is equal to, all right, so 5 divided by 4 plus 49 divided by 16. I don't know what 16 squared is, so I just put it in my calculator. And then I'd sort of like that to be in a fraction. Oh, isn't that wonderful? 369 over 256. I think 256 is 16 squared. Do you think it is?
Yeah.
Yeah, it is. Okay, so that's good. So that's what I've got. And this would be plus or minus. So y, no, not plus or minus yet. It's going to be pretty soon though. So I got y minus 7 over 16 is equal to plus or minus something over 16. That's 13, right? No, that's not 13. What is the square root of 369. 3 the square root of 41? Really? Which begs the issue of why 3 the square root of 41. All right, if you say so. So y is going to be 7 over 16 plus or minus 3 the square root of 41 over 16. That's good enough. We just leave it that way. Check. No, why not? Now the issue is, are we right? And because that came up that way, what do you think, Ben? Are we right?
That's what I got.
That's Ben got it. That solves the whole issue. Yeah, don't even have to check it now. That must be right. Yeah. All right, so we'll put it in our calculator and see what our calculator does anyway. Not that we don't believe Ben, but we believe you most of the time. Minus 7. Did I even do the right problem?
Yeah.
Minus 10. I don't even remember that being the right problem. Anyway, so the calculator says it's minus 0.763 and it's 1.638. All right. Okay, so we'll check the positive guy. 7 divided by 16. 7 divided by 16 plus 3 times the square root of 41 divided by, wrong place, divided by 16. And the calculator says that, yeah, our positive guy's right. So if our positive guy's right, our negative guy's right. And life is wonderful, and the problem is solved. We probably would want to do something clever like, put solution set brackets around there. Clearly, this is a tech math class. I wouldn't take off for solution set brackets, but if you were doing a calculus 1, 2, or 3 class, you'd want to put that in. Or
So either one of those answers right, or?
Oh, they're both right, yeah.
Okay.
Yeah, they're both right, yeah. Because there's 2 of them. There's a plus guy. I checked the plus guy. I didn't check the minus guy. But if the plus guy is right, the minus guy is going to be right.
So we can use the negative 7.6 or 0.763.
Yeah, you could. Yeah, yeah. So that's the issue. This would be perfectly acceptable on a test. That as your answer, or that would be perfectly acceptable. I wouldn't go and if I got here, I wouldn't go to there.
Right.
So if some reason, but if I put it in my calculator and got that, then I wouldn't try to go back up either. I just, yeah, exactly. So it's just a matter of manliness, or